I hate this noise so much, and to suppress it is a really hard task. Yes, it is silly to do with a thing that was never intended to use in this way, but even designs that are somewhat made to silence the fan don't do a good job. Not to mention that some even heavily lowers the airflow. So to fix the problem, I need to understand it first. You see, 3D printer sends a pulse power signal to the fan and it's called PWM. It switches power on and off very quickly, and the longer on signal lasts, the faster fan will spin. But if that on and off switching frequency is not fast enough and it falls within the human audible range, you probably can guess. You hear that annoying noise. So this means there are two possible fixes. We have to increase the frequency or eliminate the pulsations. The frequency can be changed in some 3D printers firmware, but that requires knowledge about editing, compiling and flashing it to a printer. Not only that, if components inside are not designed for the high frequency, they can be damaged. And this is not even a universal solution. Well then, this means that reducing pulsations is the way, and the easiest way to do that is to make a basic electronic circuit. So let me explain how the circuit works and why each component is important here. Okay, so we have the pulsating signal from 3D printer and the fan. We'll set it to run at 50% speed and you already can see how current flows to the fan with pulses. Our goal is to even out the current flow, so we need to add a capacitor. It will act as a power source when the pulse is at an off state. The only problem is that the capacitors are like sponges and draw insane amount of current when powered on. This is why we need to limit that initial current with a resistor. Without it, you could easily destroy your 3D printer's mainboard. But wait, something looks wrong, and the problem now is that the current from the capacitor flows back to the mainboard as it acts as a power source. That is why we need another component, a diode. It allows the current flow only in one direction. That is much better. And now we have eliminated all the pulses. This is before, and this is with a circuit. It completely eliminates that insanely irritating noise. But it's not all sunshine and roses. There will be a few small disadvantages. First one is that we lose around 10% of a fan performance. And the more powerful the fan, the bigger voltage drop we'll get and more energy will be wasted through the resistor. The second one is that the fan speed percentage will not be linear. What this means is that with the circuit installed, when you set fan speed to 5%, you'll get 22% when compared to before, with 10% around 37% and with 50% around 77%. Well, you get the point. This doesn't really change much as you'll only need to roughly know the corresponding values and update them in your slicer, but I will take those few disadvantages any day of the week as having printer with that high pitch whining noise is extremely annoying. So how to make one? And there are two very different ways. The first one is a little bit janky as you need to solder one component to another in mid-air, always checking the schematics where which lead goes. That will end up in not the prettiest solution, but it will do the trick. The second way is to use a custom printed circuit board, and I'm very glad that PCBWay kindly agreed to sponsor this video and also provided those gorgeous black PCBs. The advantage of this way is that it is extremely easy to solder components and the final result is very professional. So let's go over what we'll need. First are the diodes, and all of them have this marking strip. By looking at the board, you can already tell that we need to place them exactly the same as it is shown. Capacitors like this have positive and negative terminals. The negative side is marked like this and it will face to the side of the board. The big resistor direction doesn't really matter here, so we just need to solder it leaving a gap beneath as it will get slightly warm. Finally, we can add wire terminals like these to voltage in and voltage out sides. Don't forget to trim all the leads at the bottom, and now we have a properly made circuit. For the part list, where to buy them and more details, I will make a post on my Patreon page, and it will be available for everyone, so if you're having problems, please check it out. So to finish it, we just need to design and print the enclosure. The last thing that we will need is to cut wires, trim insulation, and secure wires from the printer to the in and from the fan to the out terminals. And that is pretty much it. To end the video, let's talk about the cautions of this project to be aware. Some 3D printer boards are made to cut down costs so much that they come with extremely weak components. However, after checking multiple original boards from the popular 3D printers, I can say that this is more exception than the rule. The most optimal way is just to open the bottom of the printer and check what MOSFETs are near your 3D printer fans. Then you can Google the name of it and from datasheet know how many amps they can handle. Anything above 2 amps is more than enough. The last thing that I want to talk about is the compatibility with different fans. Either 12 or 24 volt fans will work with the circuit, just make sure to use a correct value resistor for those different voltages. In both configurations the resistor limits the current to around 500 mA. You can use a lower value resistor to reduce the drop of the max fan speed, but remember that the maximum current during the charge of the capacitor will also increase. So don't go crazy, as there will be less and less benefit with lower value resistors. Not to mention that the used Schottky diode has a rating of 1 amp in the first place. Now the wattages of the fans. If your fan is around 1.2 watt, then use this enclosure as the resistor will get only slightly warm. And if your fan is twice as powerful at around 2.4 watts, then use this open style enclosure as the resistor will get pretty hot. Ideally, you want to find a spot where you can get at least some airflow from a mainboard cooling fan. And the absolute last thing to mention is the incompatible fans. The craziest part of this that I tested many fans and all of them work perfectly. The ones that didn't work are those from the KP3S 3D printer that I made this fix for. Like, really? They have this extremely weird issue. Everything is fine until you turn the speed way down, then they turn off and the resistor temperature just skyrockets. So yeah, just be aware that some weird no-name fans won't work. But again, it is more exception than the rule, same as with the weak 3D printer components. So here you go, this is all the information you must know. If you want to support my work, you can do it on my Patreon or simply by giving a like. I hope this video finally helped you solve the problem. Happy less annoying printing, and we'll see you on the next one.